пока плывут, как корабли. Теплый ветерок мчится над поверхностью земли.
In this beginner video, we will discuss Godot's main way to describe abstract reality of your games, its node tree and scene systems. We will learn how Godot builds your game's world, what is a node and why they form a tree. We will start to understand internal lifecycle of your game objects, and we will learn the second most important skill of a game developer that uses Godot, how to create your game using the fact that this lifecycle exists and tries to help you with your task. And in the end, if you listen carefully, you will get a chance to learn the first most important skill of Godot developer, how to create your game despite that lifecycle existence and its attempts to help you. So, nodes. Every game in every engine must somehow abstract game object entities. Those entities must store some data, might process that data, and must be somehow processed by the engine to do automatically some manual work we expect an engine to do, such as physically moving and colliding our physical objects, rendering visible objects, etc. Aside from some ECS-based dark magics, most of the engines we have use object-oriented paradigm, so a game entity is literally an OOP object that holds the data that describes it and has methods to work with the data and are processed by the engine, what is usually done via that object being an heir of some built-in engine type or having a composed component that is an heir of a built-in engine type, or both. In Godot, we call these objects nodes, because in Godot's hierarchy of inheritance, on the very first step of its built-in class hierarchy, we have a default base omni object being inherited by two things, node and ref counted. On this stage, both node and ref counted can hold data and process data, but on this first split, the node evolution step gets a broad engine-based lifecycle and ability to participate in that lifecycle via being a part of so-called node tree. While ref counted doesn't get that, aside from the built-in garbage collection system that counts references and frees this thing if it stops being referenced, i.e. stops being relevant to the runtime. After this class evolution step, everything that you want to have in your scene tree or node tree, which are two equal terms, is an heir of a base node class through some inheritance chain. Godot has many built-in nodes for your toolkit, and you can check their exact inheritance chain through opening a docs page for that node, or here when you create a new node, or here in the inspector panel on the right, you can see that properties of objects are grouped under these different titles. And these titles are also the steps in the inheritance chain, so you can see in practice how each inheritance evolution step adds new properties to an object, widening its area of being involved into the engine's lifecycle. So, lifecycle. In the most broad paint strokes, lifecycle of any complex framework, what game engines are, can be described as select a collection of things and run some operation on them. And if we will take small design paint strokes and start to add details, we will soon discover two important considerations. Firstly, we will often need to define sub-collections of things out of the list of all things, because not every operation needs to be run on every object. For example, only the participants of physical simulation must be checked for collisions and move with physical velocities, while for other entities such an operation makes no sense. And secondly, in a complex environment, order of operations matters. For example, for physical bodies, we want first to test a velocity movement and only then check for collisions, and in the flipped order, these operations, again, make no sense. If we were discussing an ECS paradigm engine, here we would just transition to the system's priority, order of execution, and how your component entity tags are distributed in your entities. But since we are living on the object-oriented ground here, we need some form of organization for our objects, a data structure that will give our mid-sex programmers a comfy way of managing the domain logic of our game, while simultaneously guaranteeing a manageable order of operations for our engine's internal life cycles. And for Godot game engine, this way of organizing our game object, this data structure, is called scene tree. And upon declaring it, we can say that the order of lifecycle operations is determined by the engine in the way of just running its processing functions in a strict order each frame, just like systems order in ECS, and the order of defining and traversing a subcollection of elements is decided by those elements' position in a tree graph hierarchy in which we artificially build our game from provided abstractions. By this point I probably lost most of the retention percentage, so let's finally look at some practical examples. Create a new scene, imagine it be a level in some 3D game. Now let's add here some branch node structure, and we will name our nodes as if they were listed just as ordered numbers from top to bottom. Now, to each of these nodes I will give one shared script of 3 lines. It will override the physics process function that we get when we inherit a simple node, and inside that function we will echo our node name into the console. And to highlight the frame border I will add on top here another script that will push a dash line. So, ladies and gentlemen, any guesses on what will I see in the console upon running the scene? Strictly speaking, if said plainly as this method is called when the physics server tick is processed, nothing guarantees us that they will be called in some fixed order. However, they are in fact processed one after another. To be precise, they echo their names in the order of being listed from top towards bottom. The reason for this is we didn't try to shoot our dick off by tampering with processing priorities, and the engine just defaulted to the tree traversal order for processing notification. Here it is on the screen, and yeah, it just goes top to bottom. Now let's change our labrat function to override a ready call that is being fired once when the node becomes ready to use after scene initialization. And the order, as you see, is changed. It was changed because tree traversal orders for these two processes are different. The ready call is being processed by an algorithm called children first. There is in fact another one for input processing, it is illustrated by this picture. But having a lot of input processing overrides in a bunch of different scripts is another dick shooting of practice, and I heavily recommend to avoid it. Try using centralized approaches if you can. For now, let's pause with this theme a bit. I will only say that to save your brain from concussions caused by too frequent table headbanging, it will be very useful for you to be aware of the fact that Godot nodes processing is dependent on the node tree structure you build from your nodes. We will return to this topic in another chapter about node order biting our asses during development, but for now we need to understand a couple more things about tree, nodes and scenes. Firstly, what the fuck is a scene? I'm using this word once in a while, but I want the series to be absolutely newbie compatible, so let's clear the term. A scene is just a container box consisting of several nodes that were put in some order that was afterwards saved as a blueprint and called a single node. Just like that. Encapsulation in its finest. Turning parts of your game into scenes can be beneficial if you want to reuse things often, especially if you want to spawn things during the runtime. Think an enemy or a projectile, etc. Let's create a new scene and call it an enemy. For now, all our nodes are not spatial, no 2D, no 3D, it is just an example. But imagine for a second that here we have a main script, then some simple state machine, then some collider, a weapon, a visual model, etc. This thing can quickly become a complex structure. But we want to spawn these things using a single call later, or put them onto our level with a single drag and drop. Here, scenefication comes to help us. We can save the whole piece of the tree as a single node, and when it's time to shine comes, we just put it here. Now, I want to clear some newbie misconceptions in understanding scenes. Firstly, scene is just a blueprint to create a pre-saved part of the tree and put it into the tree where you see fit. This is the beauty of encapsulation. Since all content of the scene is parented to the scene's root node, you can work with them as with a single node, but there is zero additional magics to it. This is literally just a box with some predefined node tree part, and when runtime comes, scenes are sort of dissolved. When your game is running, they aren't packed in any sense aside from this parenting relationship, and all the content is just chained onto the tree as if it was built here by hands. These two are literally the same picture when runtime starts. We can demonstrate it by printing out our tree structure on scenes ready call. We can even scenify and unscenify things here in editor. If you want to save a branch of a tree as a scene, you can right click and select this option, and if you have here a scene, you can dissolve its box container and spawn a full tree piece instead of the scene here. And this packing and unpacking action shows the difference between a scene and a node structure outside of the runtime. Again, scene is an instantiated piece of the tree that you created here by some blueprint. This can be used to your advantage. For example, when you create a level with pre-spawned patrolling enemies, you can put them onto your map as instances of an enemy scene and you're done. You then test your enemies and decide that this enemy needs a hitbox size changed. You go into your blueprint scene, change your hitbox, hit save scene, and boom, you change the blueprint. Now all your pre-positioned enemies are fixed to incorporate the change. This can, however, work against you. For example, if you want 99 pre-placed enemies to have one hitbox, no matter how tiny the change you want to do, for the 100th one, you need to reinvent something. Either have a copied scene for that exact enemy, or for that enemy you unpack the scene so it abandons the blueprint and then you make a targeted change for that exact enemy. However, if you won't create a new similar scene, that 100th enemy is now harder to copy forward. And finally, actually, specifically for pre-placed things, there is this option here called editable children. This is like a middle ground. You generally follow blueprint, but you can do some specific changes for this one. Or you can access its internals from outside the scene. For example, you can use one of its internal nodes as a value for an expert field for some external node. However, I would advise against this. Not like this is some bad practice that immediately will ruin things. The option is on the table. However, if you designed yourself into a situation when you need to use it often, that's a sign from the universe for you to change your ways. As with switch statements. Nothing criminal in using one, but if you feel like you are forced to do it, consider rethinking your abstractions. You probably missed something important when you designed this. And the final newbie bit, instantiation. Look here, this is the blueprint. It has a root node with a script attached and some children that could have other scripts, expert fields cross-referenced and whole other Godot kitchen. And when used as an instance, you see here that this is a node that pretends to be of type sample scene that inherits node. This is a trap. This script file can fool you. Attention, please. This thing here in the blueprint is a root node of type sample scene that inherits node. However, sample scene type is just this one node, only the root. This file describes one class. Sample scene class that is an heir of node. As a proper heir of node, it can be instantiated and put into the node tree. However, if you will try to do it like this, like a new object of class sample scene, you will get one node, not the scene, because you're commanding to create an object of the class sample scene here. This is a mistake people do at least like 5 times before they learn. This file has nothing to do with your scene. This file right here is the blueprint. This file describes a subtree of nodes that are organized in some way and have their scripts, expert fields, yada yada. And to instantiate this scene, you need to use this file, and you do it as follows. This operation spawns a whole subtree in the correct way. This one just instantiates your one object that is the instance of the tree root. These are not the same. Okay, now what else can we do with our tree, both in the runtime and outside? Well, we can use it to navigate our world picture during scripting. Of course, I already showed you the ability to debug print the world tree into the console, but there are much better uses. In general, navigating the tree solves you one big task, getting references to other nodes. And if you have a reference to an object, you can process it, so that's a big deal. What ways do we have here? Firstly, we have the green text. but instead of the comparing symbol, Godot's rage-bait pasta text starts from a $sign. This right here is a local tree path that can be used instead of the variable to call functions and change variables. For example, I can be perfectly sane individual and reference this node from here with an export field. Alternatively, I can hardcode a bit and use its tree path as an onReady annotation instead. And alternatively, I can be an agent of chaos and just write my scripts in this manner. This will work. This will compile, sadly. However, I preach to you, dear Godot newbie, to use green text carefully. See, there are two brothers, onReady and export annotations. Exported variable allows you to set the value using the editor's interface, and onReady requires you to provide a tree path. Some people consider an abundance of export fields as a bad practice because it clutters the inspector panel. Well, that problem is non-existent because you can just create export field groups and hide the fuck out of them. And the upside of export fields is that they are supported by editor, and editor is smart. If you take this node and reparent it around, an export field will follow it. It will only lose the value if your export field is strictly type, which, by the way, you should do, and you change the type of the exported node during refactoring. However, the green tree path here is just a text, in a text file, that is written after a $sign. And if you put your variable here onReady and then reparent it, your tree path doesn't change in the script and you need to change it by hands. In general, it is perfectly fine to set variables onReady via the tree path if you do it from the parent node and reference your immediate children without /signs. It is somewhat rule of thumbish, but the motivation is that in this case you are immune from dragging your nodes around. If you just swap places, the tree path doesn't change. And for the love of God, use strict typing, because if you want, your tree path doesn't know that your variable is of the class other than that is a node. So you won't see proper errors highlighted here outside of runtime, and your editor won't be able to suggest you the text to speed up your work. There are, however, two more ways to get the juicy node reference: groups and direct tree parsing. Let's start from the direct access. There are several functions that can help you to work with parent-child node hierarchies, but not via this rage-bait abomination, and with a nice API instead. For example, to get an array of nodes' immediate children, we can just call getChildren, and then you have an array you can do whatever with. Alternatively, you can request your parent, etc. I will show more uses for this way later down the line, but for now, what if we want to navigate some chaotic mess? What if I want, for example, to take all physical bodies on the level and turn off their collision models for some reason? And those collision shapes can be children of children of children, and different scenes can have different naming conventions for their shapes, different internal node orders, and a no level of nesting, etc. Well, there is a thing called group. In essence, you can just take any node in existence and slap onto it any number of string variable tags. For example, put all your enemies into a group called enemies, or all your humanoid enemies into a group called humanoids, beasts into a group called beasts, and turrets into a group called turrets. And then, instead of painstakingly traversing a huge ass node tree and searching for your colliders, we can just go Now, references are cool, but the tree structure gives another very important design access. It is the nature of the tree structure that organically provides most of the nodes with a parameter of parent node. In fact, every single one of them has a parent, otherwise that node is called an orphan node, doesn't participate in the lifecycle, and is probably a misdesign and must be freed to not waste your game's memory. And always having a parent provides us with a very interesting ability. We can inherit some juicy properties. Well, 2 elephants in the room that everyone instantly guesses are coordinates for spatial nodes. All 2D and 3D bodies inherit their parents' transformations, if they are not explicitly told not to. When you move the root node of your scene, all its content that has a transform property also moves, but there are much more. In fact, we know where properties live. They live in this inspector panel, and upon inspecting those, a peculiar view arises before us. A bunch of inherit words in some obscure properties we got in the very start of our class inheritance chain. You can check what those properties do in details via documentation. I believe in you. In short, there is a bunch of things that just make sense to do for children if you do it for parent. If you hide a visible object, also hide its visible children. If you disable a processed parent, also disable its processed children, etc. And of course you can touch those sensible settings with your dirty hands. What can possibly go wrong? The possibilities are infinite. In its greatness, Godot even allows us to redefine the processing order of a node relative to all other nodes if one wishes to. However, friends, disclaimer, there is a much better way to store your gun than your crutch, okay? Godot is an engine where simply changing the visual order of these things in the interface can turn a working program into a bugged one, what you need to consciously navigate around. And adding another freedom access to this equilibrium is a powerful tool, but with great power come great cathartic debugging experiences. Think like 10 times before you decide to change these settings. Finally, when we thoroughly walked through the subject of what and why the tree is, let's discuss some practical consequences of its existence. First thing that bites and will bite Godot users' asses for all eternity is the ready callback order of operations. Look at this picture again. What it tells you in human language is a node is ready when all its children are ready, and of 2 nodes on the same tree level, the top one is ready first. First thing to mention is that despite looking quirky at first, this is still the best design of all options. I guarantee you that you will feel pain at least several times working around it, but there is no better alternative, so don't whine and learn how to adapt. And the 2 biggest consequences to adapt are that firstly, no node can have an unready reference to its parent, and secondly, lower node can have an unready reference to a higher one, while the other way is, again, impossible. First thing happens because an unready reference, well, is being injected during the ready callback, and by design, during a node's ready callback, its parent is not ready yet. And the second thing happens because if 2 nodes are sitting on the same tree level, one of them is being processed first, so during this node's ready tick, this one doesn't exist yet, while during this one's, the first node is ready. This can produce some despair when trying to set up a smart task construction of several nodes in which every one of them has a reference to every other one. Things are not always fast and easy to inject. For now, I am just throwing shit onto a fan, but I will share the solution to this problem in the next chapter. And we are going into the second ass-devouring piranha pool. Frame processing marches from top towards the bottom in a way the node tree is set in editor, so your game's behavior is literally graphical interface definition dependent. This video's script already becomes uncomfortably long, so I won't include a lot of examples, but the most frequently occurring design of failure is 2 nodes that are placed on the same tree level that are both being frame-based processed and are modifying some third common parameter. Because they modify a common same parameter, they are tied and an outcome can be processing order dependent. And because they are placed onto the same level on the tree, it is very easy for your mid-psych brain to see them as things that you can drag around and swap places easily. 2 nightmare fuel materials without much details. First example is that prior to Godot 4.3 version, in some cases, your skeletal animation results were dependent on the relative position of your purple node and your skeleton on the tree. Skeleton above, one animation, skeleton below, another. This issue is now gone. Another example is that for some camera setups, the outcome of your camera behavior can be dependent on the relative positions of your character's node and your camera node. Again, camera below, silky smooth following floating inertious camera. Camera above, glitchy jittering mess. And you will tear your hair off debating internally if you are suited for game dev hobby, wasting hours rereading your flawless code that must produce jitterless results, while the course of actions to fix the bug is to literally drag one node below another. Well, I'm not here to sow fear in you people, I'm here to encourage. And there is a nuclear solution to fix all three order dependence problems. Following the best lessons of strategic geniuses of the past, instead of learning tactics against our enemy and training our soldiers hoping to get better chances in a battle we can lose, we will abandon the field and won't even fight the battle, which outcome we can't foresee. We will make our designs straight up immune to nodes 3 order. I gave 2 dangerous consequences of that order in the previous chapter on ready initializations and frame-based processing, and I will use those 2 situations to illustrate my solutions to them. First is the on-ready problem. Let's imagine we have some heavily branched structure that is full of overarching container nodes, and we want each of our container nodes to have a reference to every other container on the same level. What to do? Well, the answer is that we simply put their true field initialization phase to a place where we can strictly guarantee that every single one of these nodes is ready to be used. Look at this picture again. Any ideas? Can you pinpoint an exact callback here that will guarantee me that all nodes in the second tree floor are ready? Yep, it is the previous floor ready callback. Because ready processing tick happens in the specific order called children first, it is strictly true that by the time the common parent is having its ready method being called, all its children and all children of their children are ready. And technically speaking, we don't wait any additional time because we are still processing the ready notification, and no processing notifications are being invoked before the tree is ready. So we wait, but our waiting is never too late, it is just in time to do our magic. And here, in the common parent, we are free to manipulate our ready children however we see fit. We can show their values into references, we can change them, we can show them to one another, etc. And from here arises the tag of quotes late reference injection. And you can actually see this design in most of my not newbie works. Let's look at my character controller. So here I have 2 split state machines for torso and legs, and those state machines are actually multi-layered as well. And I want all my torso states and all my leg states to have a reference to other components of the scene and to both state containers. So what I do is here in the common parent nodes ready function I call my state machines to finally initialize my states fully. By this time I guarantee that all those nodes are ready to use in Godot sense, but they are not usable to do actual work. All their internal fields are nulls because they don't have references to my system's components. So here I just fill all those internal references with actual values, and for container nodes those values actually come in form of the export field, because as we discussed previously, export fields are immune to nodes being dragged around. And because my state machines are multi-layered and many of my states have states themselves, guess what? I set all the fields and then I just call the true initialization method for each of my states so it can forward those fields to its children. And voila! With this design I can freely drag around all those nodes in this subtree as I see fit. None of my initialization is dependent on the tree order. Also, here in this function you can see an example of using direct tree parsing arsenal to produce quite an easy to read code. And the second practice illustration for frame-based processing actually lives in the same project, or can be found in my public controller project's code. Again, this is an implementation of state machine base designed for a 3D character controller. Its state machine evolved quite heavily over the year I played with it, and its capabilities are insane. We have many logical layers here, we know some advanced floor locomotion, we can have branched combo-based fighting, and there were some very powerful climbing projects in the past built on this base. However, despite me having this much logic layer components here, any guesses, ladies and gentlemen, how much process and physics process methods do I have here in this whole player behavior model scene? 0. I have none. Reaching back to this philosophy, if two nodes that are both being physically processed can bear a slightest risk of having a liability of their processing order biting me in the ass, why should I even have any of such two nodes? How do you physically process your character? You surely do use some form of move and slide. What is the trick? The trick is actually very similar to the previous practice. Despite having 0 physics process methods defined, my controller is still physics process update based, and my whole character has one such method. Here in the top node of the character, which has a model scene placed as its child, I override physics process once, and from here I kick my own update calls instead. When physics scenefication comes, I gather inputs, and then I just command my model to update. And my model here has a very smart update sequence that runs all its modules in a strict order, does all necessary decisions, and consistently simulates me my frame results. By doing so, I become immune to nodes placement. I can drag my model, view and controller nodes here freely. It won't change anything, and I can drag my model's content nodes here, and again, won't ever change a thing. Because by stripping my nodes from the right to physically update and centralizing all decisions in one place, I eliminate any potential double readings of the situation. My execution cycle is completely independent from the recomposition of my scenes, obviously aside from literally missing a needed node. And my main controller cycle is completely code-driven and again unchangeable here. What makes this system very future-proof? Insert a joke about a Russian praising the absolute centralization of decision points in the system, huh? This message applies only to my code. Please make your real-life systems independent agents based, otherwise they will become future-proof in the sense of not having any future set for them. Thanks for watching, and as always, this excuse of a channel still holds thanks to my wonderful patrons, so know your heroes, folks.